Okay, so in this section, we're going to talk about relative extrema, relative extrema. So an extrema is just another word for extreme value, also known as a high point or a low point. You could call it a peak or a trough. There's many different synonyms that you can hear for these terms extrema. So there are a couple more formal ways to define these. I will let your instructor do that. I'm just going to sort of give us an easy way to identify them whenever we look at functions, whenever we look at graphical functions. So let's go ahead and just entitle the section relative extrema, relative extrema, relative extrema. And there are going to be two different types of relative extrema. There is going to be relative maximum values. And then there's going to be another type which we're going to discuss, and it's going to be called relative minimum values. So minimum and maximum apply that there's more than one. The singular of maximum is just going to be maxima, and the singular for minimum is going to be minima. So when you hear maxima and minima, that just means there's just one max or just one min. So let's go ahead and just give an informal definition. So we're just going to talk about an informal definition, and I abbreviate definition by DEF to the nth power. So that's how I write definition. So if you see that in my notes, that just means DEF to the nth power is just a name for definition. So we always talk about, especially in algebra, we always talk about functions. So we're going to suppose that f is a function, that f is a function. That f is a function, and within f, there's a value c. There exists a value of c in our function f. So as I am writing this, let's go ahead and draw what we're saying. So we have some function f, and here I'm just going to call some value of c. So we have some value c. It's in the domain of our value f. So c could be 3, it could be 5, it could also be negative 3 or negative 5. I just wrote it on the right side of the y-axis because I like working in positive values, but that's just me. Let's go ahead now and discuss the definition of our first category, which is going to be that relative max definition. So we'll say that our functional value at c is a relative max, is a relative maximum if there exists any open interval I containing our value of c such that f of c is greater than all other values in the interval. So how do we usually see this in the textbook? They usually get a little bit crazy, and they say that f of c must be greater than f of x. And this is going to be for all, and the abbreviation for all, every time you see the upside down A, you're going to see this, and this will stand for all. This is just a mathematical term. Upside down A is just a for all x in I, where x does not equal to c. So that's how you would see the math term. I don't like using a lot of math terms, especially at more of an elementary level. I think that could be a little bit more perplexing. But all we have to do is discuss what this means. So let's go ahead. I'm just going to go ahead and draw us a function as a relative max. So I'm going to draw a parabola that opens down, and it looks something like this. So a parabola that opens down, it looks something like this. So it says there's going to be a functional value here. So this will be the functional value f of c. It's going to be our functional value f of c. They say there has to be some interval I. It has to be some interval I. I don't care where it is. This could be my interval I. So we could say this is my interval I. And f of c is greater than all other values in I. So notice here, here's a functional value at x, here's a functional value of x. These are all functional values, but f of c is the largest one. And that's how they formally write a definition of a relative max. So there could be multiple relative max values. There could be 3 max values or 7 max values. There's an infinite amount of maxes. So that's how they formally define a max. All a max means is that there is a peak. There is a peak somewhere in our function. So this is a peak. That's a peak value. Let's go ahead now and describe what happens if we have a relative min. So in this circumstance, I'm going to go ahead and draw one on our graph first. It might make it easier to see. So I'm going to draw it over here on the negative portion of the x-axis. And this is going to be a parabola that opens up, or a portion of a parabola that opens up. So we're going to say that in the definition, we're going to have another value of c again, and it's going to fall on now the left portion of my y-axis, so it makes c negative. So let's go ahead and just talk about the definition of how we're going to see a relative minima. So we'll say f of c is a relative minimum if there exists that same interval I, the open interval, so I have to say open interval I, containing c, such that, take a stab here, that f of c must be less than f of x. It has to be less than f of x for all other x values in the interval. And this is, again, a very informal definition. So here I'm just going to say that I have an interval that's going to go from here to here. It doesn't matter where it is, but we're going to describe the interval from here to here. So it's going to look, that's not very good. I can never draw them upside down. There we go. So here's my interval I, and notice here I have my functional value at c. So here we recognize that f of c is going to be the smallest value. It's the most negative, and anywhere in this interval it's always going to be the smallest. So we can always remind ourselves that if we ever see a trough, that is also going to be a min value. So this is how we can graphically identify one. Let's go ahead and just draw a graph on our paper, and I'm going to have a couple extreme values in there. So I'm going to use a red axis. Let's go ahead and say we have something that looks like we have a function that looks like this. There we go. So we'll say this value is -2, this value is +2, and this value is +5. So here, this is actually going to be a special circumstance where one of our extreme values is not just relative, it's actually going to be absolute, which means it's going to be the largest value in our whole entire function. So hopefully we can recognize some peaks and troughs here. So this guy right up here, we'll call this value f of -2. F of -2 is going to exist here, and hopefully we see that he is a relative max. And this is going to be when x equals to -2. So we have a relative max value at x equals to -2. Hopefully we can recognize down here that at f of 2, this value is going to be a min. So we have a relative min value. And we have a relative min value at x equals to +2. And then over here, this is going to be something that's a little bit different. So this value is a type of relative max as well. But since he is the biggest value in my entire function, he is considered an absolute max. An absolute max because he is the largest value in the entire function. So he is going to be an absolute value. And again, you could say that an absolute max is a type of relative max, but he's absolute because this function goes all the way off into -infinity over here, and it goes to -infinity down here. So he's going to be an absolute max.